Everyone, hello to everyone. I am Professor Raja, working as Assistant Professor EC Department at SNS College of Technology, an autonomous institution Coimbatore. In this YouTube video, under the topic 1990 T204 microcontroller embedded system, today I am going to discuss under the topic 8255 programmable peripheral interface. So we know that 8086 is doing arithmetic and logical operation. So based on the unit 1 YouTube video, you are knowing what are the internal architecture, the instruction set, addressing modes and interrupts usage in 8086. Now unit 2, I gave the introduction about how an interface is connected with the 8086. Now we discussed the programmable peripheral interface, that is 8255. So this ICs look like 8255. So 8255 is a IC chip based programmable peripheral interface. The Intel's 8255 is designed for use with Intel's 8-bit, 16-bit and higher capability microprocessor. 8255 is a 40-pin integrated IC, dual in-package IC model. It is flexible and economical. So this is the pin diagram of 8255. This consists of 1 to 40 pin. These are the signals available in 8085 connected with 8255. So D0 to D7, CS, chip select, reset, A0, A1 are called address line, RD bar, WR bar, PA0 to PA7 is the address line, C4 to C7 is the control bus, C0 to C3 is the control bus, BB6 to BB7, then VCC, then ground. So 8255, a programmable peripheral interface, it consists of 24 input-output lines which may be individual programmed. Two groups of input-outputs are named as Group A, which is the combination of Port A fully and Port C upper part. Group B, Port B fully and Port C lower parts are this having. Three ports are available in 8255. One is Port A, that lines are identified by the symbol PA0 to PA7. Second one is the Port B. These lines are identified by symbols P0, BP0 to BP7. Port C. These lines are identified by P0 to PC7 and PC3 to PC0. So this Port C are further divided into two models. One is the upper model, that is PC4 to PC7. Then PC Port C is under the lower type, that is PC0 to PC3. So in this block diagram, D0 to D7, that is the data input output lines for the device. All information read from and write to 8255 occurs via these 8 line only. Chip select, if this line is a logical 0, the microprocessor can read and write to the 8255. RESET reset pin, this 8255 is placed into its reset state if this input line is a logical one. So RD bar, this is the input line driven by the microprocessor and it should be low to indicate read operation to 8255. WR bar, this is an input line driven by the microprocessor. A low on this line indicates write operation. A1 to A0, these are the address input lines are driven by the microprocessor. So based on the A1, A0 chip selector, the microprocessor can choose the three ports, that is whenever CS is 0, A1 is 0, A0 is 0, microprocessor selector port A of 8255. Whenever the chip select is 0, A1 is 0, A0 is 1, microprocessor chooses the port B of 8255. Whenever chip select is 0, A1 is 1, A0 is 0, microprocessor will choose port C in 8255. Whenever chip select is 0, A1 is 1, A0 is 1, microprocessor will choose the control register of 8255. Whenever chip select is 1, then there is no connection between 8255 and 8086 microprocessor. So this is the various blocks available in 8255. By seeing this block diagram, you will identify that there are 4 important blocks are available. One is the data bus buffer, second one is the read-write control logic, third one is the group A control and group B control. At the right hand side, fourth side, group A further consists of 2 lines, group A fully and port A fully and port C upper 4 part, and the second one is the group B control, that is port B fully and port C lower part. So on the next YouTube video, I am going to discuss the various usages of these all blocks, that is how this data bus buffer are used, how read-write control logics are used, how group A, group B are used. Thank you for watching my video.